In 1951, the United States Navy deliberately sank one of its own World War II aircraft carriers off the coast of California. Not because it was damaged, not because it was obsolete, but because keeping it was considered more dangerous than destroying it. That ship was USS Independence. Today, its wreck is still monitored, not for unexploded weapons, not for fuel leaks, but for radioactive contamination left behind by early nuclear weapons testing. USS Independence was a combat ship. It served in the Pacific during World War II. It survived the war intact. What made it dangerous came afterward, when it was used as a test subject during America's first atomic experiments. Those tests did not destroy the ship, they changed it. This video explains why the wreck of USS Independence is still considered a hazard today, how radioactive material became embedded in the ship itself, and why recovery, removal, or reuse was never a realistic option. The risks are not speculative, they are documented. If you're interested in documented World War II history explained clearly and in full context, consider subscribing. Now here is how USS Independence went from frontline warship to nuclear liability. USS Independence was commissioned in 1943 as a light aircraft carrier built for speed, flexibility, and war in the Pacific. Before it became part of a nuclear experiment, before it became a radioactive wreck on the seafloor, it was a functioning warship with a crew, an air group, and a mission. That story comes first. USS Independence was a light aircraft carrier of the United States Navy, commissioned in January 1943. It belonged to the Independence class, a group of carriers built quickly by converting existing cruiser hulls into flight deck ships. These were not experimental vessels. They were wartime solutions, designed to put aircraft at sea as fast as possible, while larger fleet carriers were still under construction. During the middle years of World War II, the U.S. Navy faced a simple problem. There were not enough aircraft carriers to meet operational demands across the Pacific. Light carriers like USS Independence filled that gap. They were smaller than fleet carriers but fast enough to operate with major task forces and capable of launching and recovering combat aircraft. They provided air cover for amphibious landings, protected larger ships, and extended American air power across thousands of miles of ocean, often in areas where no fleet carrier could be spared. USS Independence served in the Pacific during the final years of the war. It carried fighter and bomber aircraft, supported fleet operations, and operated in combat zones where enemy air and submarine threats were constant. The ship was crewed by thousands of sailors and aviators over the course of its service. It launched aircraft into combat and brought them back under fire. It recovered damaged planes when there was no second deck to divert to. It functioned as an active part of the U.S. war effort, not as a secondary or experimental platform. This was a working warship, not a reserve hull or a training platform. By 1945, USS Independence was still operational. It had survived the war without catastrophic damage. Like many wartime vessels, it showed wear, mechanical fatigue, structural stress, and the limits of a design built for speed rather than longevity. But it was not a wreck, and it was not obsolete overnight. Under normal circumstances, ships in this condition would have been refitted, repurposed, or placed in reserve. That is what makes what happened next unusual. Instead of being mothballed or scrapped, USS Independence was selected for a very different role. After World War II, the United States faced a new question. How would nuclear weapons change naval warfare? To answer that, the Navy needed real ships, fully built, fully equipped, representative of the fleet that had just won the war. USS Independence was one of them, and that decision would permanently change the ship and explain why its wreck is still treated as a hazard today. When World War II ended, the United States Navy faced a problem it had never encountered before. Atomic weapons had entered the world, and no one fully understood what they would do to fleets built for conventional war. The Navy did not need theories. It needed data. What no one knew was whether fleets built for conventional war could survive a weapon that changed the rules overnight. That meant exposing real ships, fully constructed, fully equipped, to nuclear explosions and measuring what happened next. Models were not enough. Simulations did not exist. Only full-size warships could answer critical questions. Would an atomic blast sink a carrier? Would the structure survive? What happened to crews, equipment, fuel, and steel when exposed to nuclear force? To find out, dozens of ships were selected and moved to the Central Pacific. The tests were conducted at Bikini Atoll, a remote location chosen for its isolation and deep water. The operation would include 2 detonations, one in the air and one underwater. Both were designed to study different effects of atomic weapons on naval forces. USS Independence was selected as one of the target ships. It arrived intact so that the results would reflect real wartime conditions. Fueled, outfitted, carrying aircraft and equipment representative of wartime service. This was not a stripped hull or a derelict. It was a complete warship placed deliberately within the blast zones. The first detonation, an airburst, caused visible damage but did not destroy the ship. The second test, detonated underwater, produced a massive column of radioactive water and debris. USS Independence survived both explosions, but survival was not the same as safety. Radioactive material from the blasts settled onto the ship, entered its compartments, and bonded to surfaces that could not be easily cleaned. In one moment, USS Independence ceased to be a combat asset. It became something new, a contaminated structure carrying radioactive residue throughout its hull. The tests had answered one question. A carrier could survive a nuclear blast. But they raised another, more difficult one. What should be done with a ship that survived, but could no longer be safely used? That question would define the ship's fate and explain why its wreck remains a concern today. When USS Independence was sunk, it was not carrying live weapons. There were no unexploded bombs in its holds, no fuel oil waiting to ignite. The danger associated with this wreck does not come from something that could suddenly explode. It comes from something far less visible. During the nuclear tests at Bikini Atoll, radioactive material was created in enormous quantities, not only from the explosion itself, but from seawater, sand, and debris that were instantly irradiated. In the underwater tests, this material was lifted into the air as a dense, radioactive plume and then fell back onto nearby ships. USS Independence was directly exposed to that fallout. Radioactive particles settled onto the flight deck, the superstructure, and the hull. They entered open compartments, ventilation systems, and internal spaces. Some contamination remained on the surface. Some bonded chemically to paint, insulation, and metal. This was not something that could simply be washed away. Early decontamination efforts removed some radioactive material, but not all of it. Certain radioactive isotopes embedded themselves into the ship's structure at the surface level of the steel itself. Steel absorbed contamination at the surface level. Internal spaces became difficult to access without exposing workers to radiation. As a result, the ship remained measurably radioactive even after repeated cleaning. A contaminated ship is not dangerous in the way a bomb is dangerous. It does not explode. Instead, the risk is cumulative. Extended exposure increases health risks. Maintenance becomes hazardous. Routine operations turn into controlled environments requiring protective measures. For a warship designed to operate with large crews, this made normal service impossible. Removing all contaminated material would have required dismantling large portions of the ship. That process would have exposed workers, spread radioactive debris, and created a disposal problem with no clear solution in the 1940s. The ship was not beyond repair, but it was beyond safe use. This is why the wreck of USS Independence is still treated differently from most World War II shipwrecks. The danger is not hypothetical, it is measurable, and it is the reason the Navy ultimately chose isolation over recovery, a decision that would shape what happened to the ship next. Once the scale of contamination was understood, a straightforward question followed. Why not recover the ship, dismantle it, and remove the hazard? On paper, that option existed. In practice, it presented problems that could not be solved with the technology and policies of the time. Any recovery or dismantling effort would have required prolonged human presence aboard the ship. Workers would have needed to cut, lift, and remove contaminated steel in confined spaces. Even with protective measures, this meant extended radiation exposure. The risk was not immediate injury, it was cumulative harm over weeks and months of work. For a Navy that had just demobilized millions of personnel, this was a serious concern. Dismantling the ship would also have released radioactive debris into the surrounding environment. Cutting contaminated steel produces dust, fragments, and waste that must be contained and disposed of. In the late 1940s, there was no established system for handling large quantities of radioactive naval scrap. Moving the problem ashore would not eliminate it, it would relocate it. From a technical standpoint, the ship posed additional challenges. Radiation levels were not uniform. Some areas were relatively safe, others were not. A compartment that tested within safe limits 1 week could exceed exposure thresholds the next, simply due to access, movement, or disturbance. This made planning predictable work schedules difficult. It also made accurate cost estimates nearly impossible. What appeared manageable at the start of a project could become dangerous partway through. USS Independence was a wartime ship built for rapid production, not long-term service. By the early Cold War, newer and more capable carriers were entering the fleet. The cost of safely recovering and dismantling a contaminated light carrier far exceeded the ship's remaining value. From a strategic standpoint, the Navy would gain little by taking on that risk. Faced with human, environmental, technical, and financial risks, the Navy chose isolation over intervention. In 1951, the ship was deliberately sunk in deep water off the coast of California in a controlled operation intended to limit further exposure. This was not a dramatic solution. It was an administrative one, but it reflected the realities of dealing with radioactive material in an era when long-term nuclear policy was still being written. That decision explains why the wreck of USS Independence remains where it is today. The ship was not abandoned because it was forgotten. It was left in place because every alternative carried greater risk. And that choice continues to shape how the wreck is managed in the present. The wreck of USS Independence lies off the coast of California, at a depth of approximately 800 meters. It rests beyond the reach of recreational diving and commercial salvage operations. The location was chosen deliberately, deep enough to isolate the ship, stable enough to limit disturbance. This was not abandonment, it was containment. Over the years, the wreck has been periodically surveyed by scientific and government organizations. Modern, remotely operated vehicles have documented the ship's condition without physical contact. These surveys focus on structure, corrosion, and environmental impact, not recovery. The goal is to understand how the wreck is changing over time and whether it poses a measurable risk to its surroundings. Radiation levels detected near the wreck are low. They are not considered an immediate danger to the public, as long as the wreck remains structurally stable and undisturbed. But low does not mean irrelevant. Radioactive material remains contained within the ship's structure. Disturbance, through salvage, impact, or collapse, could change how that material is distributed. For this reason, the site is treated differently from conventional World War II wrecks. The safest option remains the one chosen decades ago. Leave the ship where it is and monitor it. Raising the wreck would reintroduce risks that were deliberately avoided in 1951. Dismantling it underwater would pose similar challenges. As long as the ship remains stable, isolation limits exposure, both to people and to the environment. USS Independence no longer serves a military role. It serves as a reference point, a physical reminder of how early nuclear policy intersected with conventional warfare. The wreck is not a crisis. It is a managed condition. Its continued existence reflects a balance between historical responsibility, environmental caution, and practical risk management. The story of USS Independence does not end with its sinking. It continues in the decisions made afterward, decisions to observe rather than intervene. Those choices explain why the wreck remains where it is today, and why it is still treated with caution long after the war that built it has ended. The story of USS Independence is not defined by how it sank, but by why it had to be left behind. Built for war, the ship survived combat and outlasted the conflict that created it. What ultimately ended its service was not damage, but contamination, a consequence of early nuclear testing that could not be undone. The decision to sink USS Independence was not dramatic, and it was not symbolic. It was a practical response to a problem without a clean solution, made at a time when nuclear policy was still being learned through experience. Today, the wreck remains where it was placed, monitored rather than recovered, not because it has been forgotten, but because leaving it undisturbed continues to carry the least risk. This wreck is a reminder that some consequences of World War II did not end in 1945. They were deferred, managed, and carried forward into the present.